Hi, today I am going to explain about electrochemical sensor. What is electrochemical sensor? It is a sensor which converts chemical reaction into electrical signals. When the test sample containing analyte, it reacts with biological material which leads to chemical reaction. As a result, it either produce or consume ions or electrons. This result in change the electrical properties of solution. It is transformed into signal and detected by the help of detector. When a sensor, that is an electrode, is placed in a solution, that is the sample solution, the electrode consists of a biological material. This biological material react with analytes present in the test sample. As a result, charge transfer occurs between the electrode and sample solution. This chemical reaction is identified and recognized by transducer. Transducer convert them into electrical signals. These signals will be measured and recorded. The electrochemical sensors are classified into three types. They are potentiometric sensor, conductometric sensor, amperometric sensor. Now I am going to explain about potentiometric sensor. You already know sensor, it is a device which detects analyte present in a sample solution. Potentiometric sensor means based on the measurement of potential difference or change in the potential difference, we can detect the analyte present in the test sample. The change in the potential difference is reflected in the measurement in terms of voltage. Potentiometric sensor use ion selective electrode. Ion selective electrode. This ion selective electrode detect the voltage change which is directly proportional to the concentration of analyte. This is the schematic representation of ion selective electrode. It consists of an active glass membrane which is surrounded by a biocatalyst or an enzyme. This enzyme reacts selective with the analyte present in the test sample. Inside the electrode, it consists of a HCl solution. The electrode consists of silver chloride as an reference electrode. It is also connected with an external reference electrode. When this electrode is placed in any sample solution, the analyte present in the sample solution diffuses selectively through the semi-permeable membrane. It reacts with the biomaterial, enzyme or biocatalyst present in the ion selective electrode. Chemical reactions occur. It leads to produce or consume H+ ions. Inside the electrode, it consists of HCl ions at a particular concentration. The generation or consume of H+ ions will bring difference in the HCl concentration. The concentration gradient lead to change pH of the solution. As a result, the potential difference will be altered. The measurement of voltage will be changed. It is worthy to note that the change in potential difference is directly proportional to the concentration of analyte present in the test sample. Suppose if the analyte is absent in the test sample, there will be no change in potential difference and no change in the EMF voltage. Thus, ion selective electrode selectively detects a particular ion in solution by the measurement of its voltage. This is the principle of potentiometric sensor. Now, we will discuss about the working of potentiometric sensor. This potentiometric sensor consists of two electrodes. One is reference electrode, another one is working electrode. It is also called as indicator electrode. Why it is called an indicator electrode? Because the electrode is used to indicate the chemical reactions happening in the solution. The working electrode is placed in the test sample. When the working electrode comes in contact with the test sample, the analyte present in the test sample diffuses through the semi-permeable membrane and react with enzymes or biocatalysts present in the ion selective electrode. As a result, chemical reactions occur. This leads to bring changes in the electrical properties of solution. The concentration gradient of H plus ions lead to change the potential difference. As a result, the voltage is varied. The change in potential difference is directly proportional to the concentration of electroactive species present in the sample. The Nernst equation can be written as E is equal to E naught plus RT by NF into ln A, where A is the concentration of analyte present in the test sample. The equation indicates the electrode potential of this electrode depends on the concentration of analyte. The electrode must be 100% selective for test sample. And there should be no interference of other ions the analyte present in the sample can be detected even in the range of 0.1 molar to 1 into 10 to the power of minus 6 molar concentration. The equipment is inexpensive and portable. Even though they are portable and less expensive, it possesses a major drawback. The enzyme which is used to sense the analyte must be kept in buffer solution to maintain its activity. The ion selective electrode are classified into three types. They are glass electrode for cations, glass pH electrode, solid state electrode. Glass electrode for cations, glass pH electrodes, solid state electrode. The glass electrode for cation, it is a normal pH electrode. It consists of a thin hydrated glass membrane. How this works? The analyte react with biological material present in the electrode, and due to the concentration gradient of H plus ions, it detect the sample present in the solution. The generation of electric potential depends on the concentration of H plus ions. The change in the concentration of H plus ions bring the change in the potential difference. As a result, the voltage measurements also varied. The voltage measurement is varied only in the presence of analyte in test sample. In the case of glass pH electrode, it involves the use of gas electrodes. That is, it consists of a permeable membrane which selectively allow a particular gas to pass into the electrode. This glass pH electrodes is selective towards carbon dioxide, ammonia, hydrogen sulfide, etc. If a solution consists of gas molecules, the gas molecule diffuses through the membrane and react with the biological material present in the electrode. The chemical reaction indicates the presence of gas in that sample. Due to chemical reaction, it brings change in the electric potential. Once when the potential difference is varied, the measurement of voltage is varied. It is important to note that the voltage measurement is varied only in the presence of gas. For example, you are taking a solution which consists of a hydrogen sulfide gas. When you immerse that electrode into that solution, if that solution consists of only hydrogen sulfide, then it shows changes in the voltage measurement. If the solution does not contain hydrogen sulfide, then the voltage measurement will not be altered. And this permeable membrane present in the electrode is selective only for hydrogen sulfide. It won't allow other gases to get inside. The measurement will be highly precise only when the membrane allows gases selectively. So different membranes are available for sensing different types of gases. Another electrode is solid state electrode. It consists of thin membrane of specific ion conductor. With silver sulfide and silver halides. This electrode is used to determine a specific ion conductor present in the sample. The presence of an enzyme reacts selectively with a specific ion and indicates whether it is present in the given sample or not. The presence of ion in the sample is measured by observing the changes in the voltage measurement. Here I will explain the sensing of glass electrode for cation with specific examples. Suppose if the given solution contains glucose, that is dextrorotatory glucose, D glucose, in presence of oxygen with hydrogen peroxide, glucose oxidase as an enzyme, the glucose is converted into D-gluconate with release of H plus ions. The release of H plus ions indicate the presence of glucose molecules in the water. The amount of H plus ions produced is directly proportional to the concentration of glucose. This enzyme, glucose oxidase, react selectively only with the glucose solution. Suppose if the solution contains fructose, it will not be sensed by glucose oxidase. The glucose oxidase react only with D-glucose. It will not react with other ions. This enzyme selectivity renders us to determine the presence of specific ion in a substance. During this reaction, H plus ions are produced. The amount of H plus ions bring gradient in the potential difference. As a result, the voltage measurement is changed. The amount of H plus ions produced is directly proportional to the concentration of glucose molecules. I can give one more example. So we can see many water samples consist of fertilizer like urea. The presence of urea in water sample can be detected by using the electrodes, ion selective electrodes. That is, specifically glass electrode for cations can be used. This can be explained by equations. Urea with water molecules in presence of urease as an enzyme, it produces ammonium ions. The presence of ammonium ions or the formation of ammonium ions bring concentration gradient in the solution. As a result, the potential difference will be changed and the voltage measurement will be altered. This enzyme urease reacts selectively with urea molecules present in the sample. It will not react with other molecules. Thus, if the sample contains only urea, it can react with urease enzyme and produce ammonium ions. The amount of ammonium ions produced or the concentration of ammonium ions produced depends on the concentration of urea in the water sample. The chemical reaction occurs will bring change in the electrical properties. Transducer recognize the element and convert into electrical signals which can be measured and detected by the detector. By using glass pH electrode, we can also detect the presence of ammonia gas in a sample. The same urea sample or If the test sample contains urea, is taken, in presence of enzyme, it produces ammonia gas. The formation of ammonia gas itself indicates the presence of urea in the sample. And next one is solid state electrode. This electrode is used to determine the concentration of a specific ion in a solution. For example, we shall consider detection of iodide ion in a solution. If the solution contains iodide ion, it reacts with hydrogen peroxide with H plus ions in presence of peroxidase enzyme. It produces iodine with the release of water molecules. These iodine ions react selectively with peroxidase enzyme and convert into iodine. The amount of iodine produced is directly proportional to the concentration of iodide ion. This reaction is favorable only when the solution contains iodide ion. The Nernst equation can be written as E is equal to E naught plus RT by NF into ln of I, that is concentration of uncomplex iodine, free iodine in species. An advancement of ion selective electrode is ion selective field effect transistor and metal oxide field effect transistor that will be discussed in upcoming classes. Now I will recap. What is electrochemical sensor? It converts chemical reaction into electrical signals. When electrode is placed in a sample solution, the analyte react with the sample solution. The analyte in the sample solution react selectively with the biological material, which lead to chemical reaction. The chemical reaction lead to transfer ions or electrons, or it may lead to consume or produce ions or electrons. This chemical reaction change the electrical properties of the solution. It is transformed into signals and measured by the detector. When an electrode is placed in the sample, the biological material present on the electrode surface react specifically with the analyte in the test sample. Due to chemical reaction, transducer recognize the element and convert into electrical signals. Charge transfer occurs between the electrode and the sample solution. The transfer of ions or electrons change the electrical properties, and this enables the transducer to detect the analyte present in the test sample. Detector measure and detect the analyte present in the sample. Electrochemical sensors are classified into three types. They are potentiometric sensor, conductometric sensor, amperometric sensor. I am going to explain about potentiometric sensor. You already know sensor means detecting an analyte in the test sample by measuring their potential difference. It involves use of an ion selective electrode. The ion selective electrode detects the concentration of voltage which is directly proportional to the concentration of analyte in test sample. This consists of an ion selective electrode. It consists of an active glass membrane. Inside it is filled with HCl solution. It consists of a biological material which is surrounded by a semi-permeable membrane. The analyte diffuses through the membrane and reacts selectively with the biological material present in the solution. As a result, it either consumes or generates H plus ions. The concentration gradient of H plus ions bring change in the potential difference, which lead to change the voltage. The change in voltage is directly proportional to the concentration of electroactive species. Potentiometric sensor consists of two electrodes. One is indicator electrode, another one is reference electrode. Indicator electrode, it is also called as working electrode. When this electrode is placed in a test sample, it detects the analyte by generating or consuming H+ ions. This electrode is 100% selective towards a particular ions. There should no interference of other ions in the solution. The ion selective electrodes are classified into three types: glass electrode for cations, glass pH electrodes, solid state electrodes. The specification of each electrodes were discussed with examples. Thank you.